Hello everyone. Here in this video we will see the bit plane slicing in MATLAB, which is used for image analysis and image enhancement. So as we all know, each pixel in a grayscale image, it is represented by 8 bits, and we can isolate these bit planes. So here instead of highlighting the intensity level ranges, we can highlight the contribution which is made to the total image appearance by the specific bits. Now what we'll do is here by analyzing the plane separately, we can gain the deeper insight into how the pixel information is distributed across the images. So here we will be having we are having 8 bit planes, that is which starts from bit plane 1 to bit plane 8. Bit plane 1 is the least significant bit plane. Then comes bit plane 2, that is the second least significant bit plane, and so on up to bit plane 8, that is it is the most significant bit plane. Now here we will divide these bit planes into 3 parts. The lower order bit planes, then middle bit planes, you have higher order bit planes. Lower planes are from 1 to 3, which will it will capture the fine and noisy image details. Middle planes are from bit plane 4 to bit plane 6, which will capture the moderate image detail. And here the higher order bit planes 7 to 8, these are the significant bit planes, and these will capture the overall image shape and the structure. So what we have to do here is, first we need to separate each of the bit planes, then we need to identify the lower order bits and then the higher order bits. Okay, actually we have separated this into 3 types, but here we will identify the lower order bits and the higher order bits. This is the flow of the program. Here we'll read a grayscale image, that is we'll load the image from the file. Now we have to check whether the image which we have loaded is a grayscale image or a RGB image. If it is a RGB image, then we need to convert it into grayscale image. Okay, then we'll display the image. After that we will separate each bit plane from the image, that is we will extract the 8 bit planes separately. Then we'll display the bit planes, that is we'll show each bit plane individually. Now comes the program. So here we'll start with the 3 basic commands: CLC, clear and close all. CLC, it clears the command window, that is it removes the previous text output. Then we have clear, which will remove all the variables from the workspace so that the script starts with a clean workspace. Then you have close all, which will close any open figure windows. Now we need to read an image. So in order to read the image, we will be using IAMRead. Okay, IAMRead, and here I have copied the path for the image into the variable that is given to the variable img. Okay, so here now I'm checking whether the image is grayscale image or it is a RGB image. If size of img comma 3 is equal to 3. Okay, if it is equal to 3, then it is a color image. So if it is a color image, then you need to convert that to gray. So in order to convert the colored image to gray image, we are using the command RGB to gray of image. Okay, this image, if it is color, then we need to convert it. Then here this program here this will end here. Okay, that is this if condition will end here, that is checking of the image whether it is colored or whether it is a grayscale image. Okay, then after this block is done, that is this block is done, and we know that the message the image, it is a 2D grayscale image, that is the values of the pixels are from 0 to 255. Now next we have to display the figure. So in order to display the figure, we will use here figure command, that will open a new figure window. Then we are using the subplot 3 comma 3 comma 1. So here this 3 and 3, this is the number of rows and this is the number of columns. So this command, it will divide the figure window into 3 into 3 grids, okay, of subplots, and makes the first cell active here. In the first cell will place what? Will place our image. Okay, that is this image will place here. Now that is the grayscale image. Okay, here grayscale image will place here in the first cell, and for that we are giving the title as original image. Okay, that is nothing but the label for that subplot. Next, now we have to extract and display the bit planes. For that we are using this block. Okay, that is we are using this loop here. So starting from here, for k is equal to 1 is to 8. So here this loops over the 8-bit positions in an 8-bit image. So here k is equal to 1 is the least significant bit, that is the LSB, and k is equal to 8, it is the most significant bit, that is the MSB. Next what we are doing is we are using a variable bit underscore plane is equal to bitget img comma k. Okay, now here we are using this command here, bitget. This will return here, bitget will return a matrix of the same size as the image as of this. Okay, where each element is 0 or 1 depending on whether the kth bit of that pixel is 0 or 1. Fine. So what this bitget will do, it will return a matrix, and that matrix will be of the same size of the image, that is the grayscale image, and where each element here will be 0 or 1 depending whether the kth bit, okay, kth bit of that pixel is 0 or 1. So now next is subplot 3 comma 3 comma k plus 1. So here this command, it will select the subplot number, that is k plus 1. Since k runs from 1 to 8, the subplots used are 2 to 9. Okay, so 2 to 9, and then it will fill all the places in the 3 cross 3 grid after the original image, because in the first place we have put the original image, then remaining all the places will be filled by the remaining bit planes, remaining images. Okay, so next is IAMShow logical. Here IAMShow logical bit plane. Okay, IAMShow bracket logical bracket bit plane. So this will convert the numeric 0 or 1 matrix to logical, so that the IAMShow, this IAMShow image, command shows it as a binary image. Okay, white for 1 and black for 0. So what it will do now, this bit plane, okay, here we have obtained now this bit plane, it will give the numeric values, that is 0 or 1. So here what it will do, this command IAMShow logical bit plane, this logical bit plane, it will convert, that is it will convert the numeric values which are zeros or ones in the matrix to the logical one. Okay, to the logical one, so that this IAMShow command, it will shows it as a binary image, because here it was a matrix, where here this is a matrix. Now this matrix we want to convert it into a image, so that is done by using this command logical bit plane. Okay, then here we can see where that particular bit is set across the image, and last is title bit plane comma num2 string of k. So here this will set the subplot title to show which bit plane is displayed. Fine, then we will end here, and this loop continues for all the values of k. So it starts from 1 and it ends at 8. So here this is about the program. Now when you execute this program, you will get such output. This was the original image which we are given, that is the grayscale image which we have converted. I have given the color image, it has been converted. So converted image is, we are taking it as the original image, which is the grayscale image. Now you can see here, this is bit plane 1, 2, 3, 4, 5, 6, 7 and 8. If you see from this, bit 7 and 8, these are having more information and therefore these are the significant bit planes. Whereas here 4, 5, 6, this can be considered as the middle bit planes, and bit plane 1, 2, 3, these are the lower order bit planes and these are the least significant bit planes because we are not getting much information from these bit planes. Okay. Similarly, if you take another figure, if I am taking another image of a butterfly, you will get such type of images for each of the bit plane. Now we will execute the program. Here already I have copied the program. I will run it. See, you will get this image. Okay. Now I want to change the figure here. I will take another figure. So right click on this, then copy as a path. Go to the MATLAB program and here change the path. Now remove this double quotes here, otherwise it will give error. Run. Okay, so I have taken my image only. Just a minute, I will change it to the butterfly image. So you have to do it copy as a path. Now change this path. Remove the inverted commas, double inverted commas. Run. Okay. So this is for the butterfly image. You can change the image and you can try it for other images. Hope you have understood and enjoyed the video. Thank you.